Good. Now we have access to the email and to the height values that the user is entering in the front-end interface. And now that we have access to these two values, we'll go ahead and store these values in a PostgreSQL database. And that means you need to have a PostgreSQL database server installed in your computer, and you need to create a table in that database, and then you need to create an email and a height column in that table. And once we have those, then instead of printing these two values, we'll send them in the table of your database, and they will be stored as rows. So each submission will be stored in a row, in a single row. So what you need is you need to have PostgreSQL installed. And I explained that how to install PostgreSQL in one of our previous lectures, where we built this bookstore application. So there we use PostgreSQL to store book data in the database. And so if you have problems with installing it, just locate the lecture that is about installing PostgreSQL, and you should be good to go. And one way to create database tables and to access PostgreSQL in general is to use pgadmin3. So that was installed with your PostgreSQL. So when you install PostgreSQL, PostgreSQL will ask you to provide a password, so you need to remember that. And then you open pgadmin, which is installed with PostgreSQL, and you connect to PostgreSQL server. So connect, and then you enter your password, mine is Postgres123. Yep. And then you have your databases there. I have 4 here, but you should have only Postgres if you have just installed PostgreSQL. And I'll go ahead and create a new database for our application. So new database. Let's call that height collector. You need to specify the owner, so Postgres in my case, that's the user of the database, and OK. And your database is created, but you have no tables in there. So if you expand this, you see that tables is 0 here. So we will create a table, but the way we'll create that is by using Python. Now, when we built our bookstore application with Tkinter and PsychoPG2, so we use PsychoPG2 to access PostgreSQL database. And PsychoPG2 is a library that allows you to send SQL statements to your database, so you can query data, create tables, and so on. Now we can use the same library for Flask as well, but a more commonly used library for operating with PostgreSQL databases in Flask is SQL Alchemy. And SQL Alchemy, compared to PsychoPG2, SQL Alchemy is more higher level than PsychoPG2. So in general, with SQL Alchemy, you apply operations with less lines of code. For instance, you don't have to establish a connection using SQL Alchemy and then commit the changes and close that connection. So if you don't want to use this repeated code, then it's good to use SQL Alchemy. And many people are using that with Flask, so it's good. It's a good idea to also use it, because later you may have to work with other people when developing applications. So it's good that you learn SQL Alchemy. Now, SQL Alchemy. Let me stop this. And so I'm in the virtual environment here. SQL Alchemy, I was saying that it is based on PsychoPG2. So that means you need to install PsychoPG2 first, and be careful, I'm installing this in my virtual environment, and this faces a problem with installation. And what I can do here, I'll first try to upgrade pip, so with Python and pip install upgrade pip. So, or if you are on a Linux or Mac, you probably don't have this problem, but on Windows you often have problems. Also, when you deploy the application on a server, on a live server. That server is most likely a Linux server, so you'll not have these kinds of problem. Anyway, let me try this again. So pip install CycleBG2, the same problem. So I probably need a precompiled Python library. So that is available in this page. So I'm looking for CycleBG2. Here we go. So I have Python 3.5, so I probably need this here. Sorry if you are on a Mac and Linux, so bear with me here. If you are on Windows, you may be interested on this. So I'll go now to my app folder and I'll just put this file in here, go to the terminal again, and this time I want to point to this file. So I am in this directory and point to that file and install it with pip. And that was quick. So now I'm ready to go and install the SQL Alchemy library. Again with pip. So pip install, but that will come as a Flask extension. So Alchemy. So make sure you are typing it like this. Install. And that was successful as well. So now we go to our Python script and maybe import SQL Alchemy. So from Flask, you need to do a trick here. Extensions, SQL Alchemy, import SQL Alchemy. This statement means that SQL Alchemy was installed among the folders of your Flask library, so which should be somewhere in here. And so Flask ext and then SQL Alchemy, so that should be inside that this folder. So this is a way to actually call SQL Alchemy from within Flask. So it's not a must to know, but just for curiosity. Yeah, let me close this. And good. Now, the idea is that once we have a database, we need to create a model for our database, which is a table with columns. And then we need to specify what types of columns we want. So we want integers or floats or text in these columns. And so we will write this model with Python. Specifically, we'll be writing a class here, which means that our model will be the object. So we'll create object instances out of this blueprint. So let's call the class data. And now this class will be a subclass of another class that is constructed by SQL Alchemy. So there's a blueprint that is designed to interact with a PostgreSQL database. We need to make use of this blueprint, which is already written in SQL Alchemy. What you do is you create a DB variable there, and there you'll store SQL Alchemy and the name of your app. So you're creating an SQL Alchemy object for your Flask application, which is this one here. However, at this point, you're still not specifying the connection to your database. So your Flask application still doesn't know what database to connect with. So you want to configure that using the config method. And here you pass a list which will have this name, SQL Alchemy database URI. So you are specifying the URI of your database, which is basically the address of your database in the computer where the app is running. So that would be a string like PostgreSQL in the form of URL almost, and Postgres. So you need to pass the user. So my username is Postgres, then a colon, and then the password, Postgres123. That's my password, and then the server address, which is localhost in my case. And you should write the same whether you are on a Mac or a Linux. You write the localhost there. And then lastly, the name of the database. So mine was height collector. So I had to refresh it for that to show. Collector. Yeah, that should do it. I have brackets here. No, there shouldn't be brackets there. Yeah, just like that. So basically you're setting the value of this dictionary key to this value so that your app knows where to look for a database. And then you create an SQL Alchemy object. And then what you want to do here is, from this SQL Alchemy object, you want to access the model class. So with this class, we are inheriting from the model class of the SQL Alchemy object. And then you need to tell the name of your table that you want to create. So we will create this class blueprint first, and then we'll call the class, and that operation, so when we call the class, a table will be created with columns. So now we are just giving instructions here. Table name is the special name, that will be equal to the name that we want to give to the table. So let's say data. And once you create a table, then you want to create table fields, so columns. And it would be a good idea to have an ID first. So ID and db.column method, db.integer. So that would be the data type of the ID column. And that would be a primary key. So you want to set that to true. And then we have two more fields there. So the email field, again db column, db, that would be a string, and maybe set a limit there, 120. So we'll not be accepting values that are more than 120 characters long. We want the email address to be unique. It doesn't make sense to have duplicate email addresses there. So that's good. And height equal to db.column. So don't confuse these variables with this one here, email height. So these are local variables for this function, and these also are local variables for this class. Or even better, to discriminate, I could put some underscore for these variables. Yeah, that's it. Good. So column db, that would be an integer. And yeah, that's it. And once you do that, you want to initialize the variables of your object, so the instance variables. So that would be an init function where we pass self, email, height. And yeah, that's it. And then you say self, the usual self dot email, that would be equal to the email parameter. Same for the height, self.height equals to the height parameter, so this one here. So this is initializing our instance variables, because this method is the first to be executed when you call the class instance. Now let's go ahead and create an instance of this class. And how can we do that? Well, we need to call the class. But where do we call the class? Well, we could call the class like in this script. We could say something like dot of the name of the class and brackets and so on. But that would execute the Flask app. So a better idea would be to go to the command line and trigger a Python session where we import the DB object from this script. This is where these last lines come in handy. So when we import something from the script is not executed, because the name of the script will not be main, but it will be app when you execute the script. Great. So Python, and then from app import db, and then you point to the db object and create all method. So what this will do, it will create these tables and fields using this model. Yeah, basically that's it. Let's now go to pgadmin and check if we have a table. Let's refresh the database. Tables is still 0. That should be a problem there. Let's see. Well, this took me a bit of time for me to figure out where the problem was. This is one of those scenarios that you really hate. You don't get an error from your programming language, so you have to figure it out manually to see where you have some typos or anything like that. And if we had a problem in here, we would get an error from Python. But the problem was in this line. If we had a problem in this line, we would probably get a connection error to the database. But the problem, my problem at least, was that I mistyped this SLQ Alchemy. So it should have been SQL Alchemy. I think this is good for you to know if you do the same thing. Just make sure you check this dictionary key first. So it should be SQL Alchemy Database URI. Later I'll do a feature request to the authors of SQL Alchemy to include some error handling when you mistype something in this port. Okay, SQL Alchemy and save and go ahead and try out again. And here's a tip: when you change something in your script, it's good to exit first your Python console, so your Python session, and then enter Python again, because it might happen that when you import the DB object, you might get the outdated object there without the change that you just made. So it's good to exit Python and then from app import DB again. And let's execute the create all method. So that should execute these lines of code for us and should create a table with columns. But who knows? So let's see. Height collector, this is our database. It's 0 at the moment for tables. So refresh, and yeah, now we have data and the 3 columns: ID, email, and height. And at the moment they should have 0 rows there, so we can do a query select all from data. So data is the name of our table, and yeah, we don't have any rows, otherwise well, they would have been listed in here. Great. We have a table now, and next is we want to send these 2 values to the database. So we'll be applying some queries, some SQL Alchemy queries, but in the next lecture. So see you later.